Hello everyone, today we are going to talk about electromagnetism part 2. To start with, the magnetic field due to current in a solenoid. First of all, what do you mean by a solenoid? A solenoid is a long straight conducting wire bent into a coil of several closely spaced loops as shown in the adjacent figure, such that the length of that solenoid is very large compared to its radius. As an electric current passes in a solenoid, it will generate in its neighborhood magnetic field lines such that it will behave like a bar magnet having two poles, a north pole and a south pole. As you see in this animation, when an electric current passes in the solenoid, it will generate magnetic field lines such that these lines are parallel and uniform at the center of the solenoid. However, they curl around the solenoid, resembling those of a bar magnet, having a north pole and a south pole as shown in this figure. Direction of magnetic field lines of a solenoid. The magnetic field lines inside the solenoid are nearly parallel and having the same direction. So we say these lines inside the solenoid are uniform and strong. However, the exterior field is non-uniform, much weaker, and in the opposite direction of the field inside the solenoid as seen in the adjacent figure. The solenoid acts as a bar magnet, having a north pole and a south pole determined by the right-hand rule, where we curl our fingers with the direction of the current, then the thumb indicates the direction of the magnetic field lines inside the solenoid. Characteristics of the magnetic field inside the solenoid. To represent our solenoid, we are going to use solid curves showing the side of the solenoid facing you, dotted curves showing the side of the solenoid behind. The current is indicated by arrows on the solid part of the solenoid. By curling your hands in the direction of the current, your thumb will indicate the direction of the magnetic field lines inside the solenoid by the right-hand rule. To list the characteristics of the magnetic field lines inside the solenoid. As we mentioned before, the magnetic field lines inside the solenoid are uniform, having parallel lines of action that are parallel to the axis of the solenoid, while the direction is determined by the right-hand rule. However, the magnitude of the field inside the solenoid is constant at all of its points and is given by the relation B equal μ0 N over L times I, where μ0 is the permeability of the medium inside the solenoid, B is the magnitude of the magnetic field lines inside the solenoid in Tesla, capital N is the number of turns forming the solenoid, capital L is the length of the solenoid determined in meter. However, we can denote capital N over L by small n, which represents the number of turns per unit length of the solenoid. Where do we use electromagnetic applications in real life? They exist in many applications. For example, hotel door locks, water pressure valves, MRI machines, hard disk drives, speakers, microphones, power plants, maglev trains, and cars. For example, MRI scanners are made up of a solenoid in which an electric current passes. Thus, the patient in the MRI is under uniform magnetic field as we discussed before. Thank you a lot for your attention.